Create a simple detailed drawing. In this video, we'll use the drawing workspace to create a simple drawing, identify areas of the drawing workspace, use dimensions and drawing annotations, as well as control frames to add GD&T notes. In Fusion 360, we want to get started with the supplied dataset, Simple Box Assembly. When we open this dataset, we'll note that it has several components in the design, a base, a lid, as well as 4 screws. We can tell that these are the same component because they have the numbers 1, 2, 3, and 4 after them. This will become important when we create a detailed drawing and we identify quantities on a detailed drawing parts list. But the first thing that we want to do is we want to identify how to create a detailed drawing. The first thing that I want to do is I want to select one of my components, in this case the base. I'm going to right click and I'm going to isolate it. By isolating it, we are automatically changing the visibility of all other components or bodies in the design. From here, the next thing I'm going to do is go to Design and change to the Drawing workspace. We can determine whether or not this is coming from a design or from an animation. An animation will pull from a storyboard, and that's how you would create an exploded view detailed drawing. But for now, we're going to select From Design. When we select From Design, the reference contents can be visible only, the full assembly, or we can select them at this time. Because we've used Isolate to identify the base as our component that we want to focus on, we're going to use the Visible Only option. We're going to be creating a new drawing from scratch, and we can determine whether or not we want to use the ASME or ISO standard, whether or not we want the units to be inch or metric, and what we want the sheet size. I'm going to be using all the default settings, so we'll simply say OK. Most of the design elements in Fusion 360, such as animations, renders, and even the manufacturing toolpaths, are all contained in a single design. However, detailed drawings will create a new design file for you that'll be saved in the data panel. To get started, we first need to place a drawing view. Note that the Create New and the Model Representation are grayed out because we've already decided how we're creating those references. But we can modify things like the orientation. For example, if we want to look at it from the top. We can change the scale. In this case, we want a 1:1 scale. And we have other options such as the style, tangent edge visibility, interference edges, or thread edges. I'm going to show full-length tangent edges, and I'm going to place this view in the left upper quadrant. I'll say OK, and now we've created the upper left-hand top view. From here, in the detailed drawing, we also have some tools to create, modify, and add specific elements of a detailed drawing. We want to begin by going to Create, and noting that we have several different types of views. Projected view, section view, and detail view are all going to be extremely helpful. In this case, we already have a base view, but we could add another reference design. We're going to start by selecting Projected View, selecting the view that we want as the parent, and then begin dragging these elements out, and we can even create an isometric view. Noting that if the orientation of the isometric view does not match what your intention is, we can always create a new representation. As I begin to drag this out, the position is not quite right, but I can modify that after the fact, so I'll simply place it up here, then use the green check mark to create and continue. I can select the view, then hold down the left mouse button over the gray box in the center of the view and reposition it. Now that we have our views, let's identify a few more areas of the drawing workspace. We have Drawing and Manage tabs, and on the Drawing tab we have Create, Modify, Geometry, Dimensions, Text, Symbols, Insert, Tables, and Export. These are all the various areas and elements that we might need to create in our detailed drawing. The bottom of our drawing contains a title block, and if we select it, notice that the title block is highlighted. We can right-click and we can create a new title block, edit the title block, or edit its properties. When we select Edit Properties, this will bring up various areas of the title block that contain attributes that are easily created. For example, a drawing number. If we simply select it, we can enter a drawing number that we want for this detailed drawing, and once we're done, we select Finish Properties, and that parameter is now added. From here, let's talk about adding dimensions and annotations. We have the geometry section, which allows us to add things like center lines and center marks. We're going to add center marks and zoom into the 4-bolt hole positions. And then we can right-click and select OK to get off of our center mark tool. Next, we can move on to dimensions. There are many specific types of dimensions we may need to add, but there is a single dimension tool that contains the availability of linear, aligned, angular, radius, and diameter dimensions all in one. So we're going to select dimension. I'm going to begin by creating a horizontal dimension, a vertical dimension, and we want to make sure that we are selecting the top edge and not the chamfer. Then we need to select a width dimension. We can do this on any detailed drawing view, and this will be based on specific standards that you're trying to follow. Then we can also add information about the holes, geometry on the inside, or potentially other elements of the design that are critical. I'm going to hit Escape to get off the Dimension tool and then reposition this 1.75 a little bit lower. Anytime dimension lines cross, we can use the option called Dimension Break to create a break in the dimension line to clear up any confusion. Next, let's talk about adding notes or text. By using the text option, we'll be able to add specific text to the drawing, for example, break all edges. If we simply add this note, we can type in break all edges and place that note on our drawing. If we want a note with a leader, we can use this option, or we can use the note option with the small lightning bolt icon. When we use the note option with the small lightning bolt icon, we can grab specific areas of the design and we can add symbols or text notes to them. I'm going to add a small note here called pre-drill and chamfer edge. If we want to grab specific information from the design, for example, if these holes were created using the hole tool, we can add hole and thread notes. We would select a specific edge and place the hole and thread notes. Since our holes were not created using the hole tool, we're going to skip that step, but note that it is important to add specific information, especially when you have threaded holes. Next, let's talk about symbols. In the Symbols section, we can add a symbol for surface texture, a feature control frame, and datum identifiers. There are also specific notes for welding symbols as well as taper and slope. We're going to focus first on creating datum identifiers. By selecting datum identifiers, we first need to select a reference. We can place the datum identifier. Once we're happy, we can right-click and select Continue, and then we can OK the identifier. If we want to add any more, we just continue on by adding additional datum identifiers. For example, if the B reference was going to be off of this edge, we simply need to change the identifier to the letter B and say OK. If we need to add a feature control frame, we can use that option to define the location or the geometry that's required based on our datum identifiers. Once we're happy with the location, we'll select OK, and then we can add specific information. For example, if we want to dictate the position of the hole relative to a specific geometry, we can go ahead and we can add the tolerance value, 0.005, in reference to datum B. So this specific information on the detailed drawing will help us identify tolerancing requirements, which will ultimately affect the way in which we program our parts. This is just a basic look at creating a detailed drawing sheet, but let's make sure that we save this before we move on.